Hello everyone. In this video I want to show you a few more tools and techniques in sheet metal design. So the first one is regarding the flange, right? The edge flange, or let's say a hem. So in my first video on sheet metal design, I showed you how to create an edge flange or a hem, right? So if you click on the flange, right, the edge flange, and then you click on the edge, then you can you can provide the distance, you can provide the angle, you can provide the position of the flange, and so on and so forth. Now, one of the things that I did not mention, and I thought it's good to mention it, is this guy here called Edit Flange Profile. What is this good for? So here, if you look, the flange is made on the entire edge, right? Sometimes you do not want to basically bend the entire edge, or if you do a hem on one of the edges, you might just want to have a hem on a portion of the edge and not the entire edge. That's where you can edit the flange profile. So if I click here, right, it gives me this window. Just move it out of the way. And look here, so you see that's this point, right? I can drag it, and this point also I can drag it, right? So you see here, I can exactly tell it where to go. So this is -36. I can go -30 and put it exactly where I want, right? And then I have this guy here, this length. So can I give it a dimension? So you see here is 90. Maybe I want to go 60, right? Okay. And this corner here, clearly you see that that point has not moved yet. But if I want, I can grab it and move it, right? So you see here, for example, I can grab this distance tool and provide, let's say, this offset here. Let me do it again. So if I go from here to here, right? So I put it like 30 and 30, put it somewhere in between because the whole length is 120. And then once you're done, you say finish. Okay. And now, as you can see, it creates basically a shear here and here, creates a cut, and you see now I only have a partial flange, not the whole edge. And the same thing can be made, let's say, when you want to make a hem, right? So if I say hem, and again I click here, you see it's the entire edge, but I can say edit hem width, and again here I can grab these points and put them wherever I want, right? And I can have a partial hem, and I can define these distances or use the measurement tool, the dimension, and basically provide the exact location of those, right? So now look here, this is going to be a partial hem. Again, you have small shear on both sides of it, and then you have what? You have, as you can see, a partial, basically, hem. So these are two of the things that I wanted to mention, or one major item, which is edit profile, right? The second thing I want to mention for you is called closing corners. So here, you see it says corners, right? And in one of my previous videos, I showed you a corner relief. So today I want to talk about this guy, closed corner. Okay, so for that, what I need is basically, I need to create, let's say, several flanges on the walls which have gaps between them, right? And then I go ahead and create a closed corner. So let's say here I go with the flange tool and I go on this edge and let's say 40 mils, right? And then I do the same thing on these other ones. Okay. And okay that. So now if you look, there is a gap here, right? You see clearly there is openness here. And can I make these closed? Is there a possibility for that? So in order to do that, we come here and then we say close corner, and here it says give me the faces you want to extend, and I say this face here, and then it automatically finds the other face that needs to be extended too. So you see here it has extended this and that one to bring the gap to almost 0, close it. Right now it's not perfect 0, but you can see that here I have a 0.2 mil gap between the two surfaces. If you wanted the smaller, make it 0.1, 0.05, and so on, right? And this gap between them gets what? Smaller and smaller. Now you see here, cannot close the corner. That is just too much, okay? It cannot go below 0.2 really, so it can bring it to 0.2 for you, but not smaller than that. You see here? So now the gap is what? Close, and as I said, you can repeat it on all of these other corners. So right now, here, if I choose this guy, right, again, you can see that it is extended, the other one, and then what? There we go, right? So this is one way to close a corner by extending the surfaces, right? And leaving just a small gap behind, depending on the thickness of the material and the radius that you choose for bending it. There is a little bit of gap that needs to remain. Another way that you can close a gap is if you go here and go to welded corners. Okay, so you can do the welded corners as well. So if I go here and say, hey, this area, I want you to create a welded corner. Now you see it adds the entire material necessary to completely close it without any gap, and it adds some fillet for you over here as well, and it can add the texture for a welded material. If you want, you can remove that texture, but this is interesting. Take a look. When it adds that, basically you see like it is a welded sheet metal. You see here, right? You clearly can see that. So here we go. Okay, so now if you look, you see there is nothing left. It's completely what? Completely without a gap. So these are two methods for what? For basically closing a corner. The next thing is, so let's say sometimes you have a physical object like this, a part, and you want to create a sheet metal that this guy will completely fit inside of that sheet metal. So basically you want to create a what? You want to create a container for this object, right? And the object that you have is not a regular shape, like it's not necessarily a box, so that you can easily draw the expanded version of it and then bend it, right? So if you want to create a sheet metal for this, right, and see how to cut it and then how to bend it and so on, what would you do? Because if you don't know the shape of this guy when it's flattened or unfolded, then what would you draw? How would you create your base flange? In those cases, if you have the solid object, the best way to do it is to use this command here, convert to sheet metal. So convert to sheet metal, in my first video, I showed you that you can convert a surface into sheet metal, but you can also convert a solid object into sheet metal. So look here, I say I want to convert this into sheet metal, and I said, fine. First, tell me where is your fixed surface, the surface you want to put on the table, and start bending from there. So I say this bottom surface is my fixed surface. I said, fine. How much is the thickness of the sheet metal you want? And I say 2 mils. Okay. So I want 2 mils thickness, and then it says, fine. What is the radius for bend? And I say 1 mil. Right. And then it says, on which edges do you want to bend? Okay, so let's say I want to bend on this edge, right? I want to bend on this one. Want to bend on this guy and this one. so far it is going to create all of these shaded surfaces for me. And once I have that, then this top surface I'm gonna bend over there and then over this guy to create these two surfaces, and I also would need to bend over this one to create that guy, and then over this one to create this surface. So you see now I have what? I have all of the surfaces taken care of, and there are other parameters here for the K factor, for the corner defaults and everything. So let's just go ahead and okay that with the corner relief that we have, the rectangular relief, and look, this is what you would be getting, and you can flatten that and you can look at what the thing that you need to be cutting, right? So you need to cut something like this with those corner reliefs that you can see, and then on those lines you need to what? You need to bend it, okay? So if you bend this or remove the flatten, you clearly can have something that is going to give you that sheet metal. So this command is very, very powerful, and it does the job very fast. Okay, so as long as your sheet metal contains a solid object or something, you can easily do that with this command. Now, as I said, when you flatten this, right, you have this thing that you need to cut, this sheet metal. The last thing I want to tell you is about the cut list. So under the sheet metal, if you expand, now you have a cut list, okay, and this is the sheet, and this is the cut. What is the cut list then? So you need this sheet, but how would you cut? What is the cut list? So if you right click here, sorry, on this one, on sheet 1, and go to properties, it also gives you some information. First of all, let me tell you about those, and then we go back. So one of the things it gives you is the bounding box length and the width. So you see here, this is the width and the length of the bounding box in inches. So this guy here that you can see, right, this rectangle, that is your bounding box, and these are the sizes of what you need. And then you have the sheet metal thickness, which is basically 2 mils or about 0.78, or round to 2 decimals, rounded 0.08 inches. And then bounding box area with this is the whole area. This is removing the blank parts, just keeping the solid parts, right? And then here it gives you also the mass of the sheet metal and some other useful information. Okay, so this is about what? This is about the cut list and the properties of it that you might see in a SolidWorks certification exam on sheet metal design, right? In a professional advanced sheet metal design. There is one other command that I think I have not talked about, and that is this guy, the meter flange, which basically inserts a series of flanges on the edge of a sheet metal part. So let me show you that one as well. So here we have a flat plate, and then it says, okay, you can insert, as I said, a bunch of flanges provided by a profile on the edge of a sheet metal, right? So here, if I click here, it asks me to provide basically a face or edge. If I provide edge, it's going to be a plane. It creates a plane perpendicular to that on which I am going to draw my sketch. So if I choose that edge, you see it created a plane for me, right? And it set the origin there, so now I can see normal to it with Control 8. And then let's say I provide a profile, something like this, for example, and can provide some dimensions. And then we can go ahead and, so let's see, let's add just a few dimensions. And then you can provide these angles here. And this is one of those other items that you might see in the certification exam. The reason you see my computer is so slow because I'm recording at the same time that I am basically doing SolidWorks. So, okay, I did the sketch. And now I'm ready to create the meter flange. So here we go. As I said, it is doing two things at the same time, but there we go, right? So now you can see it. This is the meter flange. And the good thing is, actually, it provides a radius itself. So you can see that radius here and here. And then you can basically change the position of that. You can provide some gap if you want, and you can have some offsets. So if you don't want to do it all through this edge, you can do a partial, right? So here, if I don't want to go through the entire edge, just a portion of it, then I can provide some offset here, right? So I can say, hey, the first 1 inch on the left side and maybe the last 1 inch on the right side, I don't want anything. And then I okay that. There we go, right? So you see, I got the what? I got the meter flange, as you can see. Also, you might say, can I go with more than one edge? Or since I chose that edge, I have to only go along that edge? The answer is no. You can go with more than one edge. So here, for example, if I choose that edge as well, you can see that this new flange is added to that edge, and then in between the areas, you see the trimming is already done, right? And then you can go for this one as well, right? And then you can go for the next edge. So let's do the last one, see if it can close it. There we go, and we okay that. And we got ourselves what? The problem. It says the meter flange interfere with each other. Increasing the gap width might work. So here I need to make this number bigger, but how much? Remember, the thickness of the material is 0.08 inches or 2 mils. So I assume this number should be bigger than that. So if I go with like 0.1 inch or something like that, that should allow me to create the meter flange. So let's try that and see if that much of gap will do the job, and you see that it does. Okay, so this is a little bit different than the swept one that could go all around, right? This one will have to leave the gap. Okay, I wanted to finish the video, but really just saw two other commands that I have not really talked about much, and that is rip and insert bend. So I said, let me cover everything I know about the sheet metal in this video, so I don't have anything extra to say. So let's say here you have a shell, right? And you want to convert your shell that you made in part design, you want to convert it into sheet metal, correct? So you want to make a sheet metal like this, basically. And I showed you that you can use this tool here, convert to sheet metal, right? Which will leave some, of course, reliefs on the corners. Or the other way you can go about it is to use the rip to first basically cut the parts through these edges, okay, and separate them. And then what? Insert the bend so you have the filleted or the bent corners, right? The bent edges, and then you can flatten it and then see the stretch of it, and then you can cut it and then do the physical sheet metal work. So here I show you, you go to rip, and here you need to select internal edges, okay? Sharp internal edges like this, no fillet on them. So here you see that it is going to separate them with that much of the gap, right? And you can, if you say change direction, then you might only separate them along one, right? So if I say, look, point one along that, then only in one direction you're gonna have the gap, right? But if I say that, no, do it in both directions, right? So let me do it again. So here I choose this. Now it is gonna cut point one and point one on both sides like this one. Okay, so here, that's what I do. I separate them on all of these four edges, right? So here is one, and then there is another one here. And now you can see that the material is ripped. And now, still not a sheet metal, but now if I insert bends by holding this fixed face, and then the bending radius here, I choose it 0.05, and I OK that, then it is going to create bends. You see here, you see they were sharp. Now there are bends. So now this is converted into a what? This is really sheet metal. You see, you can flatten it. There we go. So now I can take this and go ahead and basically create this object for myself. So that's the difference between what? Between rip and bend and convert to sheet metal. Convert to sheet metal basically is really good for a lot of applications. You can go convert the surface to sheet metal, a solid object into sheet metal, a shell like this into sheet metal. You can do all of them. But this rip typically and bend are used for the objects, the parts that are already like a shell themselves with uniform thickness. So you have to do rip, you have to do bend, and then you can create a what? You can create a sheet metal, and you don't have to have corner reliefs here or anything because you already ripped the material a little bit. But remember that when we did this one, we had to do what? We had to provide some corner reliefs right here, and then typically, as I said, we mostly use it for solid objects. So now I guess I can finish this video because I told you everything that I know, and hopefully this video is useful to you. Thank you so much, and I'll see you in the next video.